Okay, so here we're looking at the factorial function as a start. And the factorial function is just defined as n factorial, n with an exclamation mark, is equal to n multiplied by n minus 1, multiplied by n minus 2, multiplied by, and so on, all the way down to multiplied by 2 times 1. So what we're essentially saying here is we're going to take a number, okay, and as soon as we want to take its factorial, we're going to multiply it by every number smaller than it, all the way down to 1. So let's look at a couple of examples then. If we take 3 factorial, that is just 3 multiplied by 2 multiplied by 1, and that ties up to give us 6. If we look at a second example, take 6 factorial, and that's going to be 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. You get the idea. Tidy it up, gives us 720. Extending the way that we can see that, so we won't just see factorial on its own. It tends to come as part of a thing, so we might see it as, say, 6 factorial over 3 factorial. So if we consider what it is that's there, we've got 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 over 3 multiplied by 2 multiplied by 1. What we're looking to do is cancel out what we can, and actually from the top and the bottom we can get rid of the 3 times 2 times 1 part, and that leaves me with just on the top 6 multiplied by 5 multiplied by 4. 5 4s are 20, 6 20s are 120. That's what that tidies up to be. And if we look at one final example, let's consider it in a little bit more abstract terms. So we've got n factorial over n minus 3 factorial. And again, I'm looking here just to try and tidy this up, simplify it, see if there's a nicer way of putting it. So considering what is on the top then, we've got n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, and so on. So what we can do here is we can say, well, if we're just going to multiply it by every number smaller than that, one step at a time, we can actually make it multiply by n minus 3 factorial, and that kind of keeps that pattern going for us. All of this was divided by n minus 3 factorial, and so hopefully now it becomes a little bit more apparent why we decided to stop there, because we've got n minus 3 factorial on the top, n minus 3 factorial on the bottom, and they cancel out. And so that leaves me then with just n lots of n minus 1 multiplied by n minus 2 as our tidied up version.